right, today discussing different types of chemical reactions, and there's millions of types of chemical reactions out there. And it would be a complete waste of brain power to memorize every single one of them. So we have classification systems that we can use to better identify what type of reaction it is and to help us predict what types of products will occur. So the first type of chemical reaction I would like to talk to you about is something called a synthesis reaction. A synthesis reaction is also called a combination reaction, and what it is you have two elements or two compounds and they are going to combine to form one. So your generic equation in this is A plus B yields AB. So if you think of the word synthesis, this makes sense. Maybe you think of synthetic, so making something new. And that's exactly what's happening here. So to show you an example of this, and I'm not balancing today, I am simply showing you how to identify what type of reaction this is. So we have magnesium, and it is going to react with a nitrogen gas. Nitrogen is diatomic, so A plus B, and it is going to yield magnesium nitride. So that is synthesis. Two, form one. So your next type of reaction is going to be a decomposition reaction. And your decomposition reaction is what it sounds like. So we have, maybe if you think of breaking down, rotting, decomposing. So we have one reactant here, and it is going to break apart into two or more elements or compounds. So we always start off with a compound on the reactant side, but we may end up with an element or more on the product side. So an example of a decomposition reaction is we have calcium carbonate. So there's your A. So AB is your compound, and it is going to yield, decompose. And by the way, this reaction, typically they require energy. This requires heat, which is indicated by the Greek letter delta. And it is going to break down into calcium oxide, so A, and carbon dioxide. So AB yields A plus B. So there is your decomposition reaction. So the next example that I'm going to talk to you about is called your single replacement. And your single replacement reactions are how you know that it's a single replacement reaction is you have an element and you have a compound, always that, and it is going to produce a different element and a different compound. So this element is going to kick out this element, provided that this reaction occurs. So in order to determine whether or not that this will actually happen or not, we have to consult something called a activity series, and I will do a whole video on that. But just to do a quick example with you for this, so we have aluminum. There's your element A, and it is going to react with copper 2 chloride. So Cu, Cl2, swap and drop. And that aluminum is going to kick out the copper. And so then we're going to have AC. So aluminum is going to then bond with your chloride. So aluminum chloride and copper. So AC. So you see this aluminum kicks out this copper, produces aluminum chloride, and you're left with copper by itself. So that is your single replacement reaction. So the next example that I'm going to talk to you about is called a double replacement. And double replacements are exactly what they sound like. So you have to have two ionic compounds here. So AB plus CD. And what happens is your cations and your anions are going to exchange. So this cation A is going to bond with this anion D, and this cation C is going to bond with this anion B. And in order to determine whether or not this reaction will even happen is you're going to consult something called a solubility table. And I will do a video on how to read a solubility table at a different time. Let's do a fast example. So we have silver nitrate. So A, just silver nitrate. So AB is going to react with sodium chloride, C, D, sodium chloride, to produce. So the cation silver is going to bond with chloride. So silver chloride plus sodium nitrate. So sodium C is going to bond with anion nitrate. So that is an example of a double replacement reaction. The next one I'm going to talk to you about is something called combustion reaction. And a combustion reaction, they are fairly easy to predict and to identify. And so what you have is you have a hydrocarbon, which simply means you have a carbon, certain number of carbons bonded to a certain number of hydrogens, and it's going to react with oxygen gas. Again, oxygen is diatomic. That is why that subscript 2 is there. And very easy. So your products are always water and carbon dioxide. And now note, this is complete combustion. So in complete combustion, you have carbon dioxide. You can also have something called incomplete combustion, where instead of carbon dioxide, you have carbon monoxide produced. But I'm just going to focus on carbon dioxide today. And I will do a separate video on balancing combustion reactions. Sometimes these guys can get a little nasty to balance, but I have a very quick, fast, easy way to help you with that. So let's talk about methane, because methane is a common fuel source. You might have it at your school when you work with your Bunsen burners. So we have methane, which is going to be CH4, and it is going to react with oxygen gas, and every single time we're going to have water and carbon dioxide. That's it. Every single time for complete combustion. Okay, so the next one that we're going to talk about is going to be an acid-base reaction. Now, an acid-base reaction is actually a type of double replacement reaction. However, I find that my students, when we get to the acid-base chapter, that if they can remember this, it makes those problems just that much quicker and that much easier. So a acid and a base, and a very good indicator that you have an acid is you have a hydride cation that is attached to something, and a base is you have a hydroxide. Now note that yes, you can have bases that are other things than just a hydroxide attached, but this is a very good indicator that you have a strong base here. And very easy, salt and water. Sometimes that you can also have a gas production here. But let's just do the example that I'm going to show you is just a salt and a water. So a very common acid that we have, that we work with, is hydrochloric acid. So we have HCl. So there's our hydrogen right there. And it is going to react with, and I'm going to use sodium hydroxide, which is a strong base. And right there, there's our hydroxide group. And remember, every single time you're going to have salt and water. So I'm going to write my water. It does not matter what order you write these in. Your beaker does not know. Plus, whatever is left is your salt. So in this case, we have sodium, cations are always written first, and chloride is left. So sodium chloride, aka table salt. And that is your acid and base reaction there. And I hope that you found this tutorial helpful.
Thank you for watching. Make sure to check out my other chemistry and physics tutorials and to see my arts and crafts that were inspired by science.